So, hello. Let me just set myself up here. Bum-bum. Okay, those are my slides. So, hello. My name is Lembit Lõpp. This is me. I'm a lead engineer at a company called Pipedrive. You most likely heard of it. We're a company of 500 employees, of which we have 300 in Estonia, and altogether we have around 200 engineers. I work at a tribe. Tribe is something we call teams, but it's simply bigger, called Core. And Core Tribe is something that is working on building tools and services that everyone else is using within our organization. For example, the service which gets every request that comes to our API is built by us. So we basically validate the user, make sure he's logged in and all those things. And we also built the convention UI, and I'm going to talk about that. First off, because you're mostly students and maybe not too familiar with the lingo, I want to talk about what components are. So components are usually styled user interface elements, which can be interacted with or have a predictable behavior. Simplest example would be maybe a button. You can, of course, have a normal HTML button, but in a design system or within a component, you want it to also have specific styles to your needs. Again, you can do it with normal CSS, but a button is the simplest example, so we'll just use that. And also a component can have non-HTML variations, such as a color or a size or any other property that is needed to use a specific component. And a component library or a design system is a collection of components. They, again, vary from the simple ones, from like buttons, to more complex ones, such as modals or tooltips, which a designer can use in their design to build, let's say, a web application. And, well, the designer uses them in the design, but in the code, you already have prepared pieces which you simply can use to build your application. For example, you can just say that I want a button, and then the button with the styles you need is rendered. Within one component library or design system, the styles, of course, need to match with each other, and the components that you build work well together. And in most cases, some components even include each other. For example, when you build a form, then the form's submit button is also the regular button you would use in any other case. A component library should also include the documentation, how to use a component, and examples. So people, both designers and developers, wouldn't be confused on what's going on. Now, on to the Pipedrive part. So before moving on, I would briefly describe the architecture of Pipedrive. Pipedrive itself is a software as a service sales CRM, which means it's we have a huge web application, some mobile applications, and our clients are basically using this and running basically the application from our servers, right? And CRMs by nature are quite complex because we have lots of data, lots of views, lots of actions the customers can take. So we have lots of code and lots of things our application can do. In the backend, which isn't the primary talk at this time, we are using microservices. Maybe you've heard of it, maybe not. But basically it means that we don't have this huge set of code running for all the things our application can do, but it's split into pieces which are responsible for their own behaviors and actions. And we kind of did the same thing in the front end with micro components or microservices in the front end, which is kind of unusual because usually your application pages are different applications, but we are building a single page application, which means that when you navigate from one view to another, you're still in the same session, and your JavaScript is simply changing the views that are rendering. This is another interesting topic, which I'm not going to talk about today, but just imagine that our application is built from small pieces that have a single responsibility, and all that code is built by separate teams and deployed by separate teams and on separate times. So the application is in constant flux with all those changes. So now I'm going to talk about the reasons why we started building our own design system or component library. Even before we started doing this, we had very many design inconsistencies. During the years of building our application, we had accumulated different implementations for the same things. For example, we had 4 different implementations of icons. So there were SVG icons, PNG icons, font icons, and people were confused which ones to use, or if they should make new ones, making it even more confusing. And regarding those components we had, it was often the case that they did not work in every situation. Because when a developer would build a component, let's imagine a green button, then the next developer would maybe need a red button, and then he would have to hack his solution on top of the green button or rewrite the whole button logic altogether. Which means that you would either have a weird hack or 2 implementations of the same basically solution, and this would create a lot of confusion, especially when updating code. And when we started moving into those micro components or microservices in the front end, previously we had one single application, which was kind of fine. But when we started moving to those smaller parts, then the smaller parts wanted to use the same design. But with microservices in both front end and back end, you usually shouldn't use code from another place. Even though in web applications it's easy because CSS is basically, it applies to the whole page, and you technically can use code from another part of the application, but it's not suggested and even frowned upon. So when other projects needed it, they would either copy-paste it to their source code or do those weird hacks, and again, not the pretty solution. So our solution was the Konfluence UI. Why it's named that, I don't know, but we used the abbreviation CUI or QUI, depends on how cool you want to sound. The first idea of Konfluence UI was to provide standardized HTML and CSS for developers to use as components. It was a JavaScript library in GitHub, and you could basically install it to your project. The first version, CUI 0, was born when this JavaScript library was created, and it simply helped you render HTML components with different variations as HTML. This was implemented in very few projects, mainly because this was not very quality code. and it was outputting pure HTML, which is not that great. There was also an effort to create version 1 out of 0 with the same mindset, but it was just cancelled. Next step was the Konfluence UI 2. This was around the time when we started creating those separate components from our main application. And the separate components were mostly built using a framework called React. React is a framework where you can easily build web applications, and it's really cool. I'm going to mute that. Boink. Instead of producing raw HTML, it would basically create interactable elements that are better. So we had this designer called Karel, and he liked the React, and he actually created the Konfluence UI 2. This one was more heavily used because React was emerging and everyone actually needed the library. And it was promoted more by designers and developers, and it was all fun and games. One of the best ways to actually promote it was when the designer took the components and built the prototype, which the designers are building anyways, using those components. So instead of getting a sketch file from the designers to build the application, you got pure code. And you can just throw in the business logic and use that code, and it worked. But this was also the first time I touched Konfluence UI, because I received this code as design as code, and it was really nice, but it wasn't. It did have its downsides. I do not want to sound mean, but this was written by a designer, and this designer did not have a professional experience which you would expect from, let's say, a senior developer, which I was at that time. We basically expected higher quality from the library, but there was none at the version 2. It also had poor documentation and basically no usage examples. You couldn't see how it was used, how it was supposed to use, so it was really confusing. Developers had a really hard time using it. They basically had to dive into the code to look at the properties available or the variations available for a component. Also regarding the examples was the case that as there were none, then the components were kind of poorly tested, and they sometimes looked or behaved weird, especially when working together with another component or within a specific HTML structure. So the quality was bad, and it was people had to hack the components, override some styles to make them work. And the worst thing for a developer was that the different versions, the batch versions, the minor versions, had different HTML outputs, which meant that the same styles that were created for let's imagine version 2.1 didn't apply for version 2.2. This does not bode well with a methodology called semantic versioning, where within one major version you cannot make breaking changes. In semantic versioning, the third number, which is, let's imagine we have version 1, 2, 3, the number 3 would mean that you have created fixes or something like that. Number 2, or the second number, is basically adding new things but not changing anything existing. And number 1 is basically when you want to change something that already existed. And this was done wrong in version 2, where things were fixed with the number 2 as well, or changed with the number 2. Which meant that all of the small projects we had also had to include the styles of the version they had installed. So all of the tiny things increased their bundle sizes by basically having almost the same code as everyone else, but not exactly. So the load time for clients was also slower. So due to developer interest and all similar projects going on, me and another senior developer, Pavel, left our teams, and we created a new team called Coffee. Coffee would then start dealing with building and maintaining tools for front end. And the first tool we started building was the Convention UI. And before we started analyzing what we would have to improve in order to make Convention UI last forever, at least the next major version. So first thing we wanted to do is to split the code in two, to have one code base for the HTML and CSS and one code base for React. We wanted to do it for several reasons. One reason was that we imagined that we would have other frameworks in use in Pipedrive as well, other than React. So we would use the same HTML let's imagine, in a Vue component. But this hasn't happened yet, spoiler alert, and will probably never happen. The HTML and CSS part is basically just the styles for the components and the HTML output examples. You can't use it like on its own, because it's when you use it, you're only supposed to use the styles from it. If you want to, you can still build your application without using React, but then you have to output the same HTML that the HTML CSS part has described, and then you can have nice looking components. But the React part uses the same approach, where it outputs the HTML and then applies the JavaScript logic to it as well. So let's imagine we have a more complex thing, such as a model that can open or close or have a transition and all those cool things. Then this logic would be written only in the React part. In the HTML CSS part, there would be no logic how to actually make a component visible or something like that. Secondly, we wanted a better documentation. And we wanted the documentation to be part of the code of the component system. So also playing around with the code of a component would be really nice. So we decided to create a component playground. So when you go to a components documentation page, you see some nice text and description about it, how to use it, and then code examples, live code examples with the output displayed. So for example, we wanted all of our button color variations to be shown. We would create the code to show green button, red button, purple button, and then you would see those same buttons in the documentation page. So this was a great way to display the components as they should work, and then developers can just copy-paste the code if they want to. This was also a great way to make sure that documentation is created, because the only way for a developer building a component to see how it works is to actually write this documentation with the component examples, and then make sure that it works. So when we started building the components, we just created the documentation page, wrote the descriptions, made the examples, and when the examples did what we expected them to do, then the component was basically ready. And we wanted the thing to be shareable between different parts. So as I mentioned before, when we used Convention UI 2, we had to include the styles and icons and whatnot separately in the bundles of the smaller parts. But we didn't want to do that anymore. We wanted the styles to be loaded once and this is why we started properly using the semantic versioning, which I mentioned before. So within one major version, it is illegal to make breaking changes. And we would try to keep one major version alive for a while. Now I can tell you that version 3 lasted for a year, and version 4 has lasted for a year as well. So this kind of works. This also meant that when designing and thinking about components, we had to think about all the variations, or the, let's say, API of a component beforehand. So you would not have the need to create breaking changes. So when a new component came in, designers gave us a specification. We would be very thorough and very critical when looking at the specification in order to make sure that we don't need to change this component anytime soon. And this did help us. So in our big, huge single-page application, we are now loading the styles only once, and it's actually kind of illegal for the sub components or micro components to load the same styles. And this makes our customers happier because the load times are faster. And code excellence. We wanted the quality to be the best because you don't want to use a library with shitty code. So we applied all the standard things, such as code linting and testing, to make sure that everything was super nice. And as we had two seniors working on it, we were very mean to each other at some points to make sure that everything is perfect. So we started building the Konfluence UI 3 with all those ideas in mind. First, we did build our own documentation environment, even though I would not suggest doing it yourself, because there are very good solutions out there, and it's kind of hard to make it good. And then we started building all our components one by one. With vacations, it took us the whole summer to build, and in August 2017, we released Konfluence UI 3. Teams started implementing it right away and migrating old projects from Konfluence UI 2. It took some time, but eventually most of our front-end projects were using Konfluence UI 3. Using the new component system was also encouraged because it had updated visuals. So when you started using it, you were using the latest and greatest. And when, let's say, visuals or colors would change, you would basically have to do nothing, because we would install the new styles to our primary application, and everyone would get those updates. And we wanted people to update, because then our application would look the same everywhere. Otherwise, it still had those quirky things happening where buttons look different or icons look different. We also had this task force, because we had this old application which was written in Backbone, not React, to convert as much of that application into Konfluence UI 3 as well. This part of the application is still the biggest part, but it took some time to use this HTML and CSS part to make it work with Backbone as well. And we could discard React at that time, which was the thing we had already planned for. And in the end, our application was mostly with the same look and feel, and we were kind of happy. And we thought that Konfluence UI was a success, the third version. Everyone was using it, and we were happy. And then the biggest sign of success for me was that people started having problems with it. So this means that people are using it, and that was great. Some components obviously had bugs, but we could usually fix it within a batch version or a minor version. And there was also a large demand for new components. or some components were hard to use, or sometimes required the same weird hack every time when you used it. So we actually started gathering issues for the next major version, and within a year we had gathered enough to actually have a reason for the next major version. So we started a mission to create Konfluence UI 4 with all the issues we have gathered. At that point, we had in Pipedrive moved to this from teams and projects to tribes and missions. I don't know if you've heard about it, but it's basically bigger teams and projects with no disturbances. Yes. So and the teams that are doing those missions are can come together from different parts of the organization. So we gathered 3 developers and the designer and built the 4th version of Konfluence UI, fixing all the tiny bits that couldn't be fixed within a major version before. And we created new components and rebuilt existing ones so it would be even nicer. And we also improved the documentation because the first version wasn't maybe that great again, because when senior developers write something and then they document it, it might not be understandable for juniors. And when you write something that is supposed to be used by everyone, it should be understandable to everyone as well. So we tried to improve on that. So Konfluence UI was launched almost a year after the launch of version 3, and it was cool. And there was a possibility for me to actually use the library I had built as well. As I mentioned before, we had the tribes and missions, which means you can get out of your part of the organization and go on a mission to do something else. So I used this chance to go on this mission or a project that was using the design system, and I was actually using it myself. This was a great experience because, again, when other people maybe sometimes saw problems in the design system, they weren't even that vocal about it. But when I used it, I found many, many issues. Fortunately, during this mission, I was able to, I think, create at least 5 new smaller versions of the design system to accommodate for the needs I had. But it was still a great experience for the builder of the tool to actually use it to know what the issues might be. So this is the story so far. I also have to mention that the design system is used by, I would say, from 50 to 100 projects at the moment, which is quite a lot. I don't know the exact number because it's hard to tell, but it's not that important as well, but it's used a lot. Regarding the future, we want it to be used in all the front-end projects, which is actually the case already. In our application, everyone who's building something, they're using Konfluence UI. If they're not, they're probably doing something wrong, or they have a really good reason not to. But we will keep on adding new components when the need arises and keep on maintaining it for as long as we need to. And there are already plans for Konfluence UI 5 because it's a year past the previous major version. And again, we've run into some trouble with some of the components and we want to completely rewrite them. Pipedrive also has a marketplace for developers where they can build their apps and integrations. So in my opinion, it would be awesome if they could also use this design system. At the moment, our design system is private, only usable in-house, but I dream about the day when we're public and everyone can use the components we have built. And we want to start building our mobile apps or app actually multiple apps now, using React Native. And when you're already used to using components in your React applications, then using a similar components in React Native applications would be awesome as well. So whenever we get this accelerated growth in our React Native applications, we will start building similar components there as well. Unfortunately, you can't share the code or the logic between them in a sensible manner, so we would have to rewrite all the components from scratch for React Native. And of course, we will keep on improving. As I mentioned before, we always need new components, we need to fix the bugs, and in my opinion, it's very, very important to make all the components simpler to use. Because most issues we have is when components do something weird or they don't work perfectly. And developers have to go around them to make them work. I want them to work out of the box and be awesome. So that's actually it. This is the story so far. I hope you have some questions about this, about anything related to our front end or design systems all in all. Thank you.
We do actually have a few questions. Let me get them out. Was it difficult to convince your managers to create a new tribe, Coffee, to build Convention UI?
Actually, it was. It was difficult because the managers we had to convince were product people. And product people want to, build. But sometimes you also need to invest in something. I like to use this analogy where imagine building one app and another, you would use, let's say, 2 units of time. Now, when building this one app and building the components as well in a shareable way, using a bit more time, you would use 1.5 units of time, let's imagine. Then, and when you're building the next application, you would need 0.5 units of time, and the next one again 0.5. So this is basically just an investment you would have to explain to the management. Building your own component system, that's a separate question. If you want to build your own, you have to have reasons for that. For example, we have a very specific look and feel, and our components have a specific interactions, right? So in order to do that, we had to build our own one. But to convince the management, you would, like with most libraries, you would just have to say that this is an investment. We will take a bit more time to do it, but when it's done, we're going to win hard, because in the end, building an application using those components is way more faster than building an application without them.
Okay. Are you planning to make your component libraries public at any time soon?
As I mentioned, then this is my wish, but this is not in the scope at the moment. I personally see no reason why any component library should be private. First off, this is front-end code, you can go and steal it anyways. And second off, having it public would mean that it's open source, most likely, would mean that you have more users, would mean that you have more problems with it, and then you have more things to fix, and then you can make the component library even more perfect. And when it's perfect for both you and public users, you would get better results even faster. So again, I would suggest doing it, but we started private, and it's hard to move from private to public.
To Pipedrive, when you want to change some framework in development, is it hard to implement, and what happens with the old code that is written with other tools? Let's say go from Angular to Vue.
This is a good question. When you have code that works, just don't delete it. When you have to rewrite or add new functionality, then just rewrite the whole thing step by step into the new parts. Our application actually consists of this huge backbone application and tiny React bits everywhere. And basically those micro components are our solution. So you create this single thing that needs to be done, right, in React or Vue or Angular, and you can actually use. It's not hard to use even, let's say, Vue component inside React. It's a bit hacky and ugly, but you can do it. So start with small steps. Don't think about converting everything at once. Just whenever you need to change a thing in let's say a bigger manner, then just start rewriting it in a new framework. And don't just rewrite it into a new framework because it's cool. Rewrite it into a new framework when there is a reason to. For example, from Backbone to React, there's a really good reason, because React is way more performant with its virtual DOM and all those nice things. But let's imagine from React to Vue, no point, because they're basically the same. Or even React to whatever the thing Dan Abramo was talking about in his Twitter, no point, because it's such a small gain. But whenever you need to work on something, think that maybe I can rewrite this as well.
Do you plan to rival Bootstrap or Bulma at any time in the future?
No, there's no need to, because first off, they have their specific things. Bootstrap isn't, I wouldn't even say, a good example. I would want to rival Material UI maybe, but not Bootstrap. But there is no need to, because we have specific requirements. We have a specific design, and that's why there are hundreds of design systems out there. There are resources. You just Google design system, React design system Vue. You find so many different ones. If you're building, let's say, a hobby project or making something that isn't important to have your own design, just go find one that suits your needs and start using it. Like again, for example, when you use Material UI, it might not work for your project because the design or the component behavior is not what you need. Pick what you need, use it. We needed to build our own, so we're using our own.
Can we get some examples how does CUI workflow look like? And if you can, please show us.
Workflow. This is a good question because I don't understand it. If you mean the components workflow or the building of a component workflow.
Can someone explain the question? Yeah. Mm-hmm. Okay, I get it. So basically, how Convention UI is used. Fortunately, I have my laptop here. Let's see if I can get the screen. So I do have to do a small trick. 1 second. You know, VPN, very, very secure. We don't have any bad things. I will show you the documentation page we have with the code examples and all that. But it's in our internal network, so I need to go to the VPN real quick. So I'm with my back. Let's open this thing. So this is I'm going to zoom in once. So this is our documentation. It's not that nice because it's basic. But let's take, again, the most simplest example. So this is the documentation page for the button, where we explain how it works, what it does, And then we have 2 sections for it, the React section and the HTML CSS section. I'll start here. This basically explains what the class you should use, is what you should use, all the different modifier classes. For example, when you apply the green class, then you get the green button. And the button S, you get the small button. And here you can see how they look. So different variations in all their nice colors and weird things. And don't mind the weird intent, but this is the code example where you would use the same HTML, for example. You just write the button with the specific class names. And in the real part, the React part, is basically the same. You would have the list of properties you can use for a component, where you can see all the options that are available. And again, we have the code examples. Here we have all the colors, and here's the code for all the colors. So button blue is this blue button. I suddenly want to make it red. It's a red button. So this is the playground where you can play around. And you can just copy this code to your project, and it works the same. Gives you the exact same output, and it's really cool. And with the more complex components, I'm going to show you model, right? So with model, we have a lot more properties, as you could imagine. And the example, which is this button that opens a model, shows a model, you can close it. The example here is a, hello, click to your work. The example here doesn't open. Let me refresh the page, maybe something happened. I've had trouble with Chrome being slow lately. I don't know why. Or something else went wrong. Either way, the example, this example would show the React class code, where we're using state and all those nice things to display the component. But I think it's broken. So yeah, those are the examples. This crashed, so I can't show you more. Yoink. Or maybe we can. Let's see. Let's try the other version. Okay, so here we have a more thorough example with all those states and whatnots you need in React, and how we need to display the model and the trigger button to open it. So we have a button and a model, and this button on click opens the model, and all the nice things that are inside the model are described here. So this is the playground we use to document, and where we can get examples of how to use components. Does this answer your question? Good.
What are some of your personal favorite pre-made component libraries?
I think I already mentioned that Material UI looks really strong. I would definitely use it in my personal projects. There was one other, I can't remember the name, which we used quite heavily as an example for our own one. It wasn't Material, but it was something. There are so many to choose from, but I would say Material and others.
Okay. Does anyone else have any questions that they want to ask personally? No? Well then, I thank you very much for coming.
Yep.
Thank you.
Thank you. Okay. Aitäh.